Okay, so inequalities, I think are often an overlooked part of mathematics, right? But yet we use inequalities a lot. Like think about like a speed limit, right? So like this, what's the speed limit on the freeway? 65, right? 65, okay. So, I mean, do you have to be going 65? No, right? If there's traffic, you'd be going a lot lower. So you can be going 65 miles an hour or what? Or less, right? Well, we use inequalities whenever there are multiple answers, right? Whenever there is a range of answers, right? When we have an equation, then we get x equals 5. And that's just one answer that it could be. But an inequality allows for a giant range of answers, okay? And we have 5 inequality symbols that we're going to go over that I'm pretty sure that you're very, very aware of, okay? So number 1, what is that symbol right there?
That is less than.
Nope, try again. That's greater than, right? So as an example, why would we ever use that? Because, 5 is greater than 3, right? That's what that means. 5 is greater than 3. As an example, 5 is greater than 3. Okay, good. That's one of them. Okay, if you know that one, do you know this one?
That one is greater than or equal to?
Greater than or equal to. So as an example that we could say, well, 5 is greater than or equal to 5, right? Notice the difference between the two. One of them allows you to say it's strictly greater than something, and the other one allows you to say it's greater than or it's equal to. So notice the examples that I give, right? Sometimes it's so trivial, but yet it's often overlooked in algebra, okay? So let's see number 3. So if I gave you that symbol, Will, this is your time to shine, buddy. If I gave you that symbol, what would it be, ready? That would be less than, exactly. So as an example, I think 7 is less than 11. Is that true? Is 7 less than 11? Sure is, right? If I have $7, you have 11, I have less than you, right? Okay. So 4, what do you think the next one's going to be by process of less than or equal to? Okay, you got it. Not really process of elimination, but just the process, I suppose. So I could say 7 is less than or equal to 7. Is that true? Is that still a true statement? Right? I'm making true statements as we go along. Okay. Okay, I said there were 5 of them. What's the other one?
Equal to.
No, that's the equation. Oh, we're talking about an inequality. Not equal to. Very good. Okay, good. So the other one is this symbol. Like, can someone give me an example of that? Make one up really quick.
2 is not equal to 100.
2 is not equal to 100. You know what? I agree with that. So everything that we said on the right-hand side, that's all true statements, okay? Let's see. Okay, so the first thing that we talk about with inequalities is we learn how to graph them on a number line. Okay, do you see that little symbol there? It's an R with a line through it, okay? Yeah, who has seen this symbol right here? It's an R with a line through it. My middle table has seen this symbol. This number, or this symbol right here, this represents all real numbers, okay? All real numbers. No. So the way that you make this is what I do is I make 2 parallel lines, and then from the back one I just make an R like that, okay? Oh, like that? Yeah, okay, I've seen that before, but it's technically supposed to go through it. So the way that I make this symbol and the way that you see it in the book a lot is I just make 2 lines and then I make an R like that, okay? That symbol stands for all real numbers, okay? So that includes all whole numbers, integers, rationals, right? Irrationals, like the square root of 2. That's all part of the real numbers, okay? So I want us to graph all real numbers x less than or equal to -7. So here is how I want you to make your graphs, okay? Give yourself a line, a straight line, and give yourself arrows on both sides. Why do we want arrows on both sides? What does that indicate? Just spit it out, anybody.
Going on infinitely.
Yeah, okay? It goes on forever and ever in both directions, okay? That indicates that it goes on forever and ever. Okay, now, then you have to give me 0 on your number line. You have to give me 0. And it doesn't matter where you put it. The only thing that matters is that you put the next number in the right location. So if I'm graphing all numbers that are less than or equal to a -7, where does the -7 go? To the right of 0 or to the left of 0? It goes to the left of 0, and it doesn't matter to me where you put it as long as it's just to the left of the 0. Is that fair enough? Okay, now I want to represent all numbers x that are less than -7 or equal to it, okay? So how many answers could there be? Infinite. Alice, you're absolutely right. There's infinite answers, okay? So there's not just one or two or three. There's an infinite amount of answers. So how do we do this, all right? The way that we do it is we put an open circle above the negative 7. And then we ask ourselves, well, is it less than 7, negative 7, or is it less than or equal to? And what is it in this case? Less than or equal to. So in that case, then we color the circle in like that, just a little bit. And then which direction do we draw the arrow? We draw it to the left. And actually, I should be doing all of this in a different color so you can see. So it'll be blue. And then we go to the left. And I like to shade like this. It's not necessary, but I like to do that just to make it look really cool because I'm half artist. You don't have to do that part, but you do have to have the arrow going to the left, okay? So this is a graphical representation of every real number x that is less than or equal to negative 7. Okay, here we go. Let's do all real numbers x greater than or equal to 1.5. We'll do this one a little bit faster than the last one. Okay, so we're going to go ahead and draw our number line. Give me 0 somewhere on the number line. And now let's talk about 1.5. Where's 1.5? To the right or to the left of the 0? Has to be to the right, so I'll put it anywhere you want. Doesn't matter to me where you put it anywhere you want. All right, now I want all real numbers that are greater than or equal to that. So I'm going to put an open dot, and then I'm going to color it in because it's greater than or equal to, and I want my arrow to the right, and I'm going to shade, so I want every single real number that is greater than or equal to 1.5. Okay, after we know what an inequality is, after we know how to graph an inequality on a number line, then we start moving up into solving inequalities, okay? Now if you read this, this is not an equation. Why is this not an equation? Because there's no equal sign, okay? So this is an inequality, right? It looks just like an equation. We treat it just like an equation, but there could be many, many, many answers to this, not just one answer, okay? So we treat this as if it were an equation, and we proceed. So if I have 2x plus 1 is greater than negative 3, I want to isolate the variable just like I would as if it was an equation. So I would subtract 1 from both sides first, okay? And I would get 2x is now greater than negative 3 minus 1 is negative 4. Everybody on board with that step first? No big deal, right? Okay, so 2 times the number is greater than negative 4. What am I going to do now? Everyone spit it out real quick. I'm going to divide by negative. I'm going to divide by 2 on both sides, excuse me. So I'm going to get the statement x is greater than negative 2. Okay, x is greater than negative 2. This represents for us a bunch of answers, right? Can you think of any number that's greater than negative 2? Yeah, we could be here all day staying this game, right? So instead, what we do is we say, okay, this is 0. Okay, here's negative 2. Notice it's to the left of the 0. I put an open dot above negative 2, and I want all numbers that are greater than negative 2. Well, those happen to be in this direction. Okay, all of these numbers are greater than negative 2. Now, it's very, very important to make this statement here, okay? If I have x is greater than negative 2, okay, can I say this? Negative 2 is less than x. Okay, the question, are these the same? Are those the same thing? Yes or no? If you're not sure, just make a statement that's true. Give me a number that's bigger than negative 2. Okay, 3 is greater than negative 2. Now go to the bottom one, right? Reverse it. Is negative 2 less than 3? Are those both saying the same thing? They are saying the same thing. Okay, I want to make this point to you, right? They are both saying the same thing, okay? I prefer this one, and I'm wondering if you can figure out why I prefer that one. Why is that one easier for most students to understand how it's graphed on the number line? Did anybody see it? Yeah, Will, what do you see, buddy?
Well, I noticed that the greater than sign is like pointing this way.
Yes. Okay, so here we go. You're exactly right. If your variable is on the left, right, x is greater than negative 2, okay, then your graph will match the direction of the inequality sign. Do you see that? So it's greater than, and my graph is going the same direction. Notice that this one, right, this is less than, but yet my graph is still this. The graph doesn't change, but I have two different ways of saying the same thing, but the graph stays the same. So I encourage all of my students to write an inequality with the variable on the left. Okay? That way it'll match your graph. It's not wrong if you write it the other way, but it is a little bit confusing for some students to make sense of the correct graph. Do you see what I'm trying to say here? Okay. So I would highly encourage you to write the variable on the left-hand side, all right? But it's not wrong if you don't. Okay, here we go. What I am looking for is I'm looking for a statement that I could write down algebraically using inequalities that represents the graph that I have just given you so far. Okay? So, can you give me a number that is in the highlighted region that's on the number line? Can you give me a number? 5. Yeah, 5 would be about there, right? That would work. Give me another one. 6. 6 would also work. That's about there. Give me 3. I think 3 is over here somewhere, right? What else? 4. Are there any others? Yeah, how many actually are in between there? An infinite. We could be here all day doing that, okay? So how do we say this, all right? Well, we notice that 2 is on the left, right? 2 is the leftmost point of my interval, right? This is an interval. What's the rightmost point? 7. Put a 7 over here. Now, okay? And I'm looking for numbers that are between that. So x is going to be between 2 and 7, right? But how do I have the inequalities? How do the inequalities go? Well, if that x wasn't there, 2 would be blank to 7. Would it be equal to 7? No. Would it be less than, it would be less than 7, right? So 2 would be less than some number x that I am picking, and that number would be less than or equal to 7. So this is how we would write, it's called a compound inequality. This is how we would write the inequality to that picture right there, and that's how we would say it. So we'd say, okay, well, all numbers between 2 and negative 7. So we would say 2 is less than x, x is less than or equal to 7. Why is it less than or equal to? Because of what? It could be 7, right? 7 could be in there, right? 2 could be less than 7, and 7 is less than or equal to 7, okay? Okay, how would you say that one? Daniel, what do you say, buddy? X is strictly less than 1. Absolutely. X is less than 1. Is there another way that I could write that?
Yes.
What's the other way I could write that? 1 is bigger than x, right? Do you see how this one, to me, makes more sense to write it like that, right? I want all numbers that are less than 1, right? This is still okay. This is technically not wrong because 1 will be bigger than the number you pick, but it's more confusing for some students, okay? So I would highly recommend that we just stay with this way. So x is less than 1. Okay, how would we say this statement here, this little graph here? X is greater than or equal to negative 6. Yeah, absolutely. That's how I would recommend saying that statement right there. X is greater than or equal to negative 6. Okay, solving graph. A little bit of practice for us. Lots of examples. We've got x minus 15 is greater than negative 12. What should I do first? Brandon, what should I do first, buddy?
You should subtract the 15.
Subtract the 15? I'm already subtracting 15.
Or you add 15.
Add 15. There you go. That's what I think you meant to say. Add 15 both sides, okay? Add 15, right? So I get x is now strictly greater than negative 12 plus 15. How much is that worth, everybody? 3. Good. So then I can graph this on the number line really quickly. Here is 0. Here is 3. I would have an open circle, and it would be pointing to the right. Okay. Another quick little example. Daniel, what should I do first, buddy? Daniel says to add 5 to both sides. Add 5 to both sides. Notice we're doing the inverse operations. So I get n is now less than what? Positive 2. Quickly on the number line. Here we go. I need 0. I need 2, which is to the right. I need an open circle above 2, and I'm going to the left because I want all numbers that are strictly less than positive 2. Okay, you guys try this one in your groups right now. Negative 1 is greater than or equal to y plus 12. Please make sure you solve it and graph it on the number line. Okay, some people were challenged by this one, so let's walk ourselves through it, all right? So the first thing I'm going to do is I'm going to subtract 12 from both sides. Did you guys do the same thing? So I have negative 13 is greater than or equal to y, right? Now, I recommend writing the variable on the left-hand side. So that means that the equivalent statement would be y is less than or equal to negative 13, right? these two things, these statements here, the one on the top and the one on the bottom, are they saying the same thing? If you're not sure, right, just write a statement that is true. Negative 13 is bigger than or equal to negative 50, right? That's true. So if I write this the other way, is negative 50 less than or equal to negative 13? That's still true. So if you don't know, just write a statement that you do know is true and fill the numbers in, right? Okay, so that being the case, I don't need that anymore. That being the case, my graph should look like this, okay? Here's 0. Here's negative 13. It's a closed dot, and which way is it going, you guys? It's going to the left. So this is what you should have as a graph. Okay, similar to the ones we've done before, but I just threw in another variable there, right? Can we handle that? Of course we can handle that. So let's just combine like terms first. So how much is 4y take away 3y? How much do I have left? I just have a y, right? So I have y plus 2 is now less than or equal to 8. Then what do I want to do?
Y is less than, or so subtracting from both sides of y is less than or equal to 6.
Y is less than or equal to 6. So on the number line, I'm getting here's 0, here is 6. I have a dot that is colored in because it's less than or equal to, and I want everything that is to the left of positive 6.